All right, so the work-kinetic energy theorem. All this says is that the change in kinetic energy of a system or an object is equal to the sum of all the work done on that system or object. That's equal to, that means the net work on the object. So for example, you could have, say, some box or something that's on the ground, and let's say you're pushing it. So you're pushing it down at an angle with some force, F1, and there's also gravity and normal force and friction, and we can call these F2, F3, F4, and there could be more forces, but let's just think about those. So the way that you'd use this is you would say that after this goes some distance, delta r, that's the displacement vector. After it goes some distance, after all these forces act on it, mostly from your pushing and then the resistance of the friction, what you'll have is that the change in kinetic energy is equal to the work done by the one force, which is the pushing, plus the work done by the third force, plus work done by the fourth force. And so, as it was said in class, what this does, this theorem, is it work connects our energy and forces. So we can actually write each of these works as a dot product of the force times this displacement. Each of these dot products, as I'm sure you all know now, can be written as just the magnitude of the force times the magnitude of the displacement times cosine of the angle between that force and the displacement, where the displacement is something like this. And so that's all you really need to do to use the work-kinetic energy theorem. You could, for example, use it when you maybe know all the work and just the initial kinetic energy, and you could find the final kinetic energy. Don't forget that this is K final minus K initial. Or if you know how much the kinetic energy changes, and say you know these three works, you could find the work done by the fourth force. I hope this was helpful, and please check out the next video where an example of this is done.